In this video, we basically discussed about the transistor. Transistor is a three-terminal device. It has three terminals. One is called emitter, one is called base, and one is called collector. Okay? The emitter is heavily doped. That means high amount of impurity atoms are added in the emitter. Because basic aim of emitter is to emit the majority charge carrier. The majority, your basic aim is to emit the majority charge carrier so that current flows through the instrument. So therefore it is heavily doped. Base is lowly doped and collector is moderately doped. The basic aim of collector is to collect the majority charge carrier that is coming from emitter. So therefore it is moderately doped. And base is lowly doped and it is very thin. It is very thin. Base is lowly doped and it is very thin. Because basic aim of base is to control the current. Or the flow of majority charge carrier that moves from emitter to collector. So here basic aim to emitter or collector to majority charge carrier jabo hetu control kora. Tar flow to control kora. Hekane base to lowly doped. As far as the volume is concerned, the volume of collector to hodai ki thake besi thake. Tarpor emitter or volume thake aru base or volume to ki thake khub low thake. Thin buli koy. Base is very thin. Base is very thin. So in transistors, there are two types of transistors. One is called NPN transistor. Or one is called PNP transistor. So this is the collector, this is base. This is collector, this is emitter, and this is base. PNP transistor. This is emitter, this is base, and this is collector. Okay? Here, pentavalent impurity is highly added. Here, pentavalent impurity is moderately added. And here, trivalent impurity is very lowly added. Say, 100% doping is done, 70% doping is done, only 10% doping is done here. So in PNP transistor, emitter is P type, so heavily trivalent impurity are added. Moderately trivalent impurity are added, very lowly pentavalent impurity are added. Now what is the symbol? So this is the symbol. The base is always written like this. So this is called the base. Base is always written like this. This is the base. And one of them is emitter and one of them collector. It is written like this. So this is the symbol. In the symbol, it is written like this. So this is the base. And two inclined lines are given. One of them is emitter and one of them is collector. Since emitter emit majority charge carrier, to represent the emitter, an arrowhead is given. Since the arrowhead is given here, so this is emitter and this is the collector. Here the arrowhead is given here, so therefore this is the emitter and this is the collector. Now in this case, in NPN transistor, free electrons, majority charge carriers are moving from emitter to collector through the base. Yes or no? Electrons are moving from N to P. Emitter to collector through the base. That means electrons are moving in this direction. we know that direction of current is always opposite to the flow of electrons. Since electron moves like this, so direction of current will be from P to N, from P to N. Therefore, this is the representation of NPN transistor. Now, emitter is N, base is P, and collector is N. This is N type semiconductor, this is P type semiconductor. N type semiconductor is emitter, P type semiconductor is base. So it emit majority charge carrier electrons. They moves from emitter to base. Since electron moves from emitter to base, direction of current will be from base to emitter. So this is from base to emitter, therefore it is NPN transistor. In this case, emitter is P type, base is N type, and collector is P type. So what is the majority charge carrier here? Here majority charge carrier is hole. Yes or no? That means hole moves from emitter to collector through the base. That means holes are moving from P to N, emitter to base. Emitter to base, holes are moving. Holes are identical to positive charge. Holes are identical to positive charge. Since holes moves from P to N, so therefore direction of current to number ki hobo? Emitter to base hobo. Ekhane etuk ami ki boli kom? PNP transistor boli kom. This is the symbol. This is the symbol of NPN transistor and this is the symbol of PNP transistor. Jot arrowhead to thake etu emitter hobo aru baki terminal to collector hobo. Aru enike sidhake jitu line ami draw korim etu ki hobo? Base hobo. Clear is it? Yet arrowhead to core pora ase, base or pora emitter holo ase. Gotike base to P hobo. Ekane NPN transistor. Yet arrow to ki ase, emitter to base ase. Tamne etu P hobo. Again, this is PNP transistor. Is it clear? Since transistor has three terminals, in order to connect a transistor in a particular circuit, one of the terminal has to be taken as common. The transistor or ki thake tinta terminal thake, eta thake base, eta thake emitter, aru eta thake collector. So therefore, to connect it in a particular circuit, one of the terminal is taken common. So if base is common, it is called common base configuration. It is common base configuration boli koy. Jodi moi emitter to common rakho in a particular connection, if emitter is common in a particular connection, then it is called common emitter configuration. Or if collector is common in a particular circuit, in a particular arrangement, then it is called common collector configuration. Amak HS so khali common base aru common emitter to lagibo, common collector to amak nalage. Moi ako koisu je transistor has three terminals, emitter, base and collector. So therefore, to connect it in a particular circuit, one of the three terminals is to be taken common. If base is common, it is called common base configuration. That CB boli koy. Or if emitter is common, it is called common emitter, CE configuration. Or if collector is common, it is called common collector configuration. Okay, is it clear? Now, we are going to study working of NPN transistor. So there is another type of transistor, PNP. So their workings are almost identical. Only difference is that in NPN transistor, majority charge carrier is electrons. In PNP transistor, majority charge carrier is the holes. That means in NPN transistor, electrons move from one junction to the other. In PNP, holes are moving from emitter to collector. Out of three configuration, in this particular case, we take the common base configuration. So the base has to be take common. Since emitter emit majority surge carrier, since emitter emit majority surge carrier, therefore emitter base junction is forward biased. Actually, since it has three different type of transistor N, P, N, so it has two junctions. One junction is between emitter and one junction is between emitter and base, and one junction is between base and collector. But কেনেকৈ গম পালো এইটো ইমিটাৰ বুলি ইয়াৰ ভলিউমটো বেছি আছে সেইকাৰণে এইটো কি হ'ব কালেক্টৰ হ'ব ইয়াৰ ভলিউমটো মডাৰেট আছে এইটো ইমিটাৰ হ'ব আৰু ইয়াৰ ভলিউমটো কি আছে থিন আছে সেইকাৰণে বেছ হ'ব সো ইয়াত দুটা জাংচন থাকিব এটা জাংচনৰ বিটুইন ইমিটাৰ এণ্ড বেছ আৰু এটা থাকিব বিটুইন তোমাৰ কি বেছ এণ্ড কালেক্টৰ সিহঁতৰ মাজত আছে আমি ইয়াত ইমিটাৰ বেছ জাংচনটো মই কি কৰিম ফৰৱাৰ্ড বায়াস কৰিম সো ফৰৱাৰ্ড বায়াস this is n type emitter therefore negative terminal of the battery is connected to n side and positive terminal of the battery is connected to p side আৰু এই ভোল্টেজটোক আমি কি বুলি কম জানানে VEB বুলি কম VEB why VEB emitter base voltage and base is common emitter base voltage base is common VEB it should be forward bias negative terminal of the battery is connected to n side and positive terminal to the p side now collector should be reverse biased. The basic aim of collector is to collect the majority surge carrier. It is emitted by emitter. So therefore, its basic aim is to receive the majority surge carrier that is moving from emitter to collector through the base. So therefore, collector base junction is reverse biased. So collector base junction is reverse biased. It is reverse biased. Now since collector is n-type collector, since collector is n-type collector, so therefore positive terminal is added here. Since collector is n-type collector, so it should be reverse biased. So therefore positive terminal of the battery is connected to n side and negative terminal to the base. Okay, collector should be reverse biased, and this voltage is written as VCB. Collector base voltage. Base is common. ইয়াতো সব বি আছে ইয়াতো বি আছে সেকেন্ড টু মই কি লিখিছো বি লিখিছো মানে বেস টু কমন so this is collector base voltage and this is emitter base voltage this is forward bias and this is reverse bias for proper function of transistor reverse bias voltage should be more than forward bias voltage proper function or karone ইয়াৰ voltage to ইয়াতকে বেছি হ'ব লাগে সেইকাৰণে মই ইয়াত দুটা বেটাৰি ৰাখিছো ইয়াত এটা বেটাৰি ৰাখিছো ক্লিয়াৰ হৈছে নাই it was reverse bias and this is forward bias in any transistor for proper functioning of transistor emitter base junction should be forward biased then only majority surge carrier move from emitter to base and collector base junction should be reverse biased then only it will collect the majority surge carrier they reach the base from emitter the collector should be reverse biased collector base junction should be reverse biased if it is reverse biased then only what happens the majority surge carrier that is the electrons which move from n-type emitter to the p-type base will reach the collector. Okay. So this is heavily doped. So these are the electrons. It is heavily doped. This is lowly doped. So these are the electrons. These are the electrons. And it is moderately doped. So therefore less number of electrons are here. Number of electrons, charge carrier in collector is less than that in emitter. Base is lowly doped. So therefore it has only one hole. Majority charge carrier hole. Okay. This is heavily doped. Therefore large number of electrons are there. This is moderately doped. Therefore number of free electrons, present in n-type collector is less than number of electrons that present in n-type emitter. This is lowly doped, therefore one hole is there. Since emitter base junction is forward biased, so majority charge carrier move from emitter to base. Majority charge carrier বিলাক কি কৰিব এই junction to cross কৰি সিহঁতে বেছত কি কৰিব reach কৰিব এই বেছত ইলেক্ট্ৰন বিলাকে reach কৰিব এইবিলাক ইলেক্ট্ৰন কৰ পৰা আহিছে these electrons are coming from n type emitter to the p type base. Why they are coming from emitter to base? Because emitter base junction is forward biased. Now the basic problem is with the base. What is the basic problem? The basic problem is it is lowly doped. Very few majority charge carrier holes are present on the p-type base because it is lowly doped. That means out of these electrons, one electron is collected by this hole. Eta electron ki koribo? Eta electron ei hole to collect koribo. Let 10 electrons move from n-type emitter to p-type base. Since it is lowly based, only one hole is available here. So therefore, one electron is collected by this hole. So what happens to this remaining 9 electrons? So since collector is reverse biased, collector base junction is reverse biased. Since collector base junction is reverse biased, this is the contact potential. This is the contact potential or barrier electric field. And due to this, since this junction is reverse biased, due to presence of this contact electric field, these remaining 9 electrons will reach the remaining 9 electron ki koribo? They will reach the n-type. They will cross the base collector junction and reach the n-type base. Sorry, n-type collector. Is it clear? Again, I repeat it. Since collector base junction is reverse biased and high reverse bias voltage is applied, these remaining 9 free electrons which actually move from n-type emitter to p-type base will cross over to the collector region due to presence of this high contact electric field at the junction of n-type collector and p-type base. Now, এই 9টা ইলেক্ট্রন কি কৰিব n-type collector তে reach কৰিব. It is how many electron move from emitter to base? More than 10 electrons moves. So therefore, this is the direction of emitter current. Emitter electron move from emitter to base. 10 electron moves from emitter to base. So therefore, this is the emitter current. Since electron moves like this, the direction of current will be like this. One electron is collected in the p-type base. One electron moves like this. So therefore, this is the base current. and remaining electrons move to the collector region. 9 electrons are moving to the collector region. So therefore, this is the collector current. That means 10 electrons are there. 1 electron is collected here, and remaining 9 electrons reach the 10 electrons move from emitter to base. 1 electron is collected in the base, and remaining 9 electrons reach the collector region. Therefore, this is the emitter current. Emitter current is base current plus collector current. Is it clear? This emitter current is of the order of milliampere. This collector current is of the order of milliampere, but this base current is of the order of microampere. Now, I repeat korisu. N electrons move from N-type emitter to P-type base. Since emitter base junction is forward biased, is it okay? Is it clear? Now, out of the 10 electrons, 1 electron is collected by hole that present on P-type base. Why 1 hole? Because it is lowly doped. What happens to the remaining 9 electrons? These remaining 9 electrons reach the collector region, since collector base junction is reverse biased. Since very low electron flow in this part, the base current comes in the order of microampere, and emitter current and collector current comes in the range of milliampere each. So this is the function of NPN transistor. Now, in common base case, since the base is common, we generally never consider the change of base current. We already know that emitter current is equal to base current plus collector current. Since in this common base configuration, base is common, therefore we are not consider the change of base current in this case. So we study the change of collector current to the change of collector current with respect to the change of emitter current, and a constant to alpha বুলি কয়. In common base configuration, base is common, therefore ইয়াৰ change to আমি study নকৰো. সেইকাৰণে change of collector current divided by change of emitter current, সেইটো alpha বুলি কয়, আৰু এইটো কি বুলি কয়, এইটো কয় common base. এইটো কোৱা হয় common base current amplification factor. Common base current amplification factor. It is called common base current amplification factor. The current gain of common base circuit, common base current amplification factor বুলি কয়. Common base current amplification factor বুলি কয়. বুজি পাইছা না আকৰটো CURRENT current common base current amplification factor. এটা বস্তু চাবা, মাকো কৈছো বেস ইজ কমন, এখানে বেসৰ চেঞ্জটো আমি স্টাডি নকৰো, চেঞ্জ অফ কালেক্টৰ কারেন্ট টু দ্য চেঞ্জ অফ ইমিটাৰ কারেন্ট, চেঞ্জ অফ ৰেশিও অফ চেঞ্জ অফ কালেক্টৰ কারেন্ট টু দ্য চেঞ্জ অফ ইমিটাৰ কারেন্ট ইজ কল্ড আলফা. এই আলফাটোৰ নামটো কি? কমন বেস কারেন্ট এমপ্লিফিকেশন ফ্যাক্টর. It is denoted by alpha. It is a unitless constant because current and current. Since emitter current is base current plus collector current, that means that the collector current is less than emitter current. Since emitter current is base current plus collector current, this means that collector current is less than emitter current. Collector current is less than emitter current. Therefore, value of alpha is always less than 1. Collector current is less than emitter current, therefore value of alpha is less than 1. Now we want to draw the circuit diagram of common emitter configuration. So here emitter is common. This is the emitter. Arrowhead is here, therefore this is emitter. Since arrow is from base to emitter, then base should be P and emitter should be N. So therefore this transistor represents NPN transistor. It will NPN transistor represent koribo. It ami ki paise base emitter junction should be forward bias. So base is P. So therefore this is base emitter junction is forward bias. So it is forward bias. Forward bias. Base emitter junction is forward bias. So this should be base to more ki ase P ase and base to positive disu or negative to port disu N type emitter disu. Base emitter junction is forward bias. Tak moi keneke likhim VBE. VBE. Base emitter voltage. Emitter is common. Ekane emitter to second of division. V for voltage, B for base, E for emitter. And collector should be reverse bias. Yes or no? Collector base junction should be reverse bias. So collector to reverse bias koribo lagibo. Collector to ki type semiconductor? N type semiconductor. Collector to N type semiconductor. Ekane collector ami ki dim? যেহেতু কালেক্টর ইজ এন টাইপ সেমিকন্ডাক্টর কালেক্টরত আমি পজিটিভ দিম আর এইটো আমি কি লিখিম VCE বুলি লিখিম কালেক্টর তো কি টাইপ কালেক্টর আছে কালেক্টর ইজ এন টাইপ কালেক্টর সো ইট শুড বি রিভার্স বায়াস সেইকাৰণে আমি ইয়াত কি এপ্লাই কৰিছো আমি কি লিখিছো VCE এপ্লাই কৰিছো VCE লিখিছো তাৰমানে ইট শুড বি ৰিভাৰ্স বায়াস it should be reverse biased. Okay, so this will be the direction of emitter current, this will be the direction of base current, and this will be the direction of collector current. We already written that emitter current is equal to base current plus collector current. So this is the emitter current, this is the base current, this is the collector current. Now, if this current is of the order of milliampere, this current is also of the order of milliampere, and this current is of the order of microampere. Yet, emitter current and collector current to kiho thakibo milliampere thakibo or base current to microampere thakibo. So, yet amar ki ase emitter is common here. Emitter is common. Yes or no? Here emitter is common. Therefore, change of emitter current never studied in this particular configuration. Here emitter to more ki ase common ase. Emitter to common ase. Here change of emitter current to study no kore. Here আমি কি করি ratio of change of collector current to the change of base current এটো কি বুলি কয় beta বুলি কয়. Ratio of change of collector current to the change of base current. Yet emitter current to kyo study no kore change of emitter current to emitter to common ase hekan ami study korisu change of collector current divided by change of base current tamane etu output current etu input current hotai variation to keneke study kore variation of output current by variation of input current etu beta buli koy aru ei beta to ki buli koy this beta is called common emitter. It is called common emitter current amplification factor. It is also a dimensionless and unitless constant. Current common emitter current amplification factor. Common emitter current amplification factor. Itu beta বুলি কোৱা হয়. এতিয়া চোৱা collector current to কি হয় আছিল collector current to milliampere range আছিল আৰু base current to microampere range আছিল হেখিনি beta value to তোমাৰ কি হয় of the order of 100 থাকে beta value to of the order of 100 থাকে আমাৰ physics lab SSN physics lab যিবিলাক transistor আছে তাত আমাৰ experiment এটা আছে we have to find out the common emitter current amplification factor in a common emitter circuit. In that particular experiment, we are getting the value beta in the range of 80 to 90. কিন্তু কালেক্টৰ কাৰেণ্টটো কি থাকে মিলি এম্পিয়াৰ ৰেঞ্জত থাকে বেছ কাৰেণ্টটো মাইক্ৰ' এম্পিয়াৰ ৰেঞ্জত থাকে সেইকাৰণে বিটাৰ ভেলুটো তোমাৰ কি হয় বিটাৰ ভেলুটো অফ দ্য অৰ্ডাৰ অফ 100 হয় অফ দ্য অৰ্ডাৰ অফ 100 হয় অ'কে now we want to find out the relation between alpha and beta relation between alpha and beta alpha to আছিল common base current amplification factor and it was a common emitter current amplification factor ইহঁতৰ definition দুটা ফাইভাৰ সুধিব ফিজিক্সৰ প্ৰেক্টিকেল ফাইভাৰ সুধিব আমি কি পাইছিলো ইমিটাৰ কাৰেণ্ট ইজ বেছ কাৰেণ্ট প্লাছ কালেক্টৰ কাৰেণ্ট so change of emitter current is change of base current plus change of collector current so ইয়াৰ পৰা আমি তো পাম change of emitter current is change of base current plus change of collector current এতিয়া মই এই ইকুৱেশ্যনটো কি কৰিছো চেঞ্জ অফ কালেক্টৰ কাৰেণ্ট দি ডিভাইড কৰিছো চেঞ্জ অফ কালেক্টৰ কাৰেণ্ট দি এটা মই কিমান পাম চেঞ্জ অফ ইমিটাৰ কাৰেণ্ট বাই চেঞ্জ অফ কালেক্টৰ কাৰেণ্ট চেঞ্জ অফ বেছ কাৰেণ্ট বাই চেঞ্জ অফ কালেক্টৰ কাৰেণ্ট ইয়াত চেঞ্জ অফ কালেক্টৰ কাৰেণ্ট বাই চেঞ্জ অফ কালেক্টৰ কাৰেণ্ট কিমান হ'ব 1 হ'ব এতিয়া মই এইটো কেনেকৈ লিখিব পাৰো 1 বাই চেঞ্জ অফ কালেক্টৰ কাৰেণ্ট বাই চেঞ্জ অফ ইমিটাৰ কাৰেণ্ট 1 বাই চেঞ্জ অফ কালেক্টৰ কাৰেণ্ট বাই চেঞ্জ অফ বেছ কাৰেণ্ট প্লাছ 1 এটা চেঞ্জ অফ কালেক্টৰ কাৰেণ্ট বাই চেঞ্জ অফ ইমিটাৰ কাৰেণ্ট কিমান তোমাৰ আলফা এটো 1 বাই আলফা চেঞ্জ অফ কালেক্টৰ কাৰেণ্ট বাই চেঞ্জ অফ বেছ কাৰেণ্ট কিমান 1 বাই বিটা তাৰমানে 1 বাই আলফা ইজ 1 বাই বিটা প্লাছ 1 সো মই এলসিএম ললে ইটো আহিব সো আলফা ইজ ইকুৱেল টু বিটা ডিভাইডেড বাই 1 প্লাছ বিটা similarly beta is equal to alpha divided by 1 minus alpha okay